Assalamu alaikum everyone. My name is Muhammad Amin. Today I am here to solve the already asked question in the Skoltech scholarship test. The question is from differential equation. Let the population of the city at the initial be n naught and evolved according to the differential equation del n by del t is equal to the 2 time of n into 1 minus n divided by 3 times n naught, where n is the population of the city after some instant of time, where n naught is the population of time at initial stage, means when the time is 0. So the initial condition here is when the time is 0, then the population is equal to the n naught original population, yeah, initial population. Okay, then when we have to find the time, what we have to find the moment of time when the population reaches 2 times n. We have to find the time interval for which the population reaches to 2 times of n, means double of the initial population. So the options are there. The option 1 is natural log of 2 by 2, B is natural log of 3 by 2, C is natural log. Now let's try to solve this one. Del n by del t is equal to the 2 times n into 1 minus n divided by 3 times of n naught. Okay. By arranging the right hand side of the equation, it becomes the 3 n naught will become the LCM, and it gives us 2 times n, 3 n naught minus n divided by 3 n naught. By rearranging the terms, the n terms in the one side and the constant terms in the other side, it becomes n 3 n naught minus n will be in the denominator, and here 2 divided by 3 n naught, it's a constant term, and the del t will be in the right hand side. Okay, let's say it's in equation 1. Okay, then because the right side integration is too much easy, because by applying the integration it's become the del t integration is just t. But what will be the integration of the left hand side, this one? So to find the integration of like this form, 1 divided by x into some constant minus x multiplied with date x, so it can be solved by using the partial fraction. We first have to divide the equation in the form of the partial form. So then we have to apply the integration. So now for finding the partial fractions of this one, we have to write 1a divided by n plus b divided by 3n minus of n. Okay, by taking LCM here, it becomes n into 3n minus n naught minus n, and those both will be cancel out because it lies in both sides. Now by multiplying these terms will be multiplied with the a and the b multiplied with the n. So the equation will be, this equation will become that one. 1 is equal to the a times 3 n naught minus n plus b times n. Okay, now say it is as equation 3. Now place the values of different possible values of n in the equation 3. So the different possible values, for different possible values, place this term 0 and n is 0. By placing 3n naught minus n is equal to the 0, it gives us n is equal to the 3 times n naught. So you have to place in equation 3 in n is equal to the 3 times n naught. In place of 3 times, in place of n, you have to place 3 times n naught. So the equation 3 becomes 1a 3 times n naught as it is, and in place of n we have to place now 3 times n naught, plus in place of n we have to place 3 times of n naught. So this will becomes 0, and this gives us 3 times n naught into b. Now 1 is equal to the 3 times n naught into b, and the b value here is 1 divided by 3 times of n. Okay, as we find out the value of b, we have to find now the value of a as it is. So for finding the value of a, we have to consider this term 0. For considering this term 0, we have to place n is equal to the 0. By placing the n is equal to the 0 in equation 3, it becomes 1 is equal to the 3 times n naught minus, in place of n you have to place 0 now. So it's become 0 plus b times 0. b times 0 is 0. So it gives us 1 is equal to the 3 times n naught into a. And now here the a value is same as it is b, it's equal to the 1 divided by 3 times n naught. Now place the value of a and b in equation 2. By placing the value of a and b in equation 2, it becomes 1 divided by n naught 3 times n, 1 divided by n 3 times n naught minus n is equal to the, in place of a we have to place 1 divided by 3 times n naught, and in place of b we also have to place 1 divided by 3 times n naught. So 1 divided by 3 times n naught is a common term. We take it as a common. So in the remaining portion we are left as 1 divided by n plus 1 divided by 3 times n naught minus n. Okay. Now in place of this we can replace it in the fraction form, partial fraction form. So by placing this value in the first equation, it gives us, in place of this one we have to place the 1 divided by 3 times n naught into 1 by n plus 1 by 3 times n naught minus n. Now the del n is present in the equation first, so it's multiplied with the 1, and it gives us del n divided by n plus del n divided by 3 times n naught minus n into whole multiplied by 1 divided by 3 times n naught is equal to the 2 divided by 3 times n naught remains as it is, and del t as it is. Now 3 times n naught and 3 times n naught here, these both will cancel out. So in the remaining portion we left with del n divided by n we now have applied the integration here. By applying integration on both sides, it becomes del n by n integral plus integral del n by 3 n naught minus n is equal to the 2 times 2 is a constant, so integral del of t. Now you know 1 divided by x del x divided by x integral is equal to the natural log of x, because in the denominator here there is a function and the numerator the derivative is present, the n derivative here is 1, so it's become natural log of function, and the function is in the denominator, that is n, so it's become natural log of n. And here in the denominator the function is present, but in the numerator the derivative of the function is not present. Now what have to do with? So just by multiplying minus we can get the derivative of the denominator. The denominator derivative here is minus 1. So minus by multiplying the minus 1, it's become minus minus plus, so it will become remain as it is. So now in the denominator there is a function, in the numerator there is a derivative of the denominator, so the formula of integration will be used natural log of function, and the function is 3 times n naught minus n, so it's become minus 3 times natural log of 3 times n naught minus n is equal to the integration of del t is what? It's just t, so it's become 2 times t plus constant of integration, or 2 times t plus c. Now the property of log is used here. If log of m minus log of n is there, and then we can write these two terms in one term, in one log, and it becomes natural log of m divided by n when these are in minus form. Okay, here natural log of one thing minus natural log of another thing, so it can be written as natural log of first divided by natural log of the second is equal to the 2 times t plus c. Okay, now we have found the general solution of the differential equation. Now we have to place the initial condition in the general solution to find the particular solution. So by placing the initial condition t is equal to the 0, for t is equal to the 0 the population is n naught. So this was the initial condition. For t is 0 the population is n naught. By placing this condition in the equation, it gives us natural log of, in place of n we have to place n naught. Okay, so natural log of n naught divided by 3 times n naught minus, in place of n we have to place n naught here, and is equal to the 2 times, for t is equal to the 0 the n is equal to the n naught, so here in place of t we have to place 0 plus c, the constant of integration. So it becomes natural log of n divided by 3 minus 1, 2. So it's become natural log of n divided by 2 times n naught, sorry. Natural log of n naught divided by 2 times n naught. The n naught will be cancelled out. So it becomes natural log of 1 by 2 is equal to the c. It can be also written as natural log of 2 power minus 1. And the power property of the log here is used. According to the power property of the log, the power comes in front of the log, so it becomes minus natural log of 2 is equal to the c. So the constant of integration value here is minus natural log of 2. Now we have to place the value of constant integration in the general solution. So it becomes natural log of n divided by 3 times n naught minus n is equal to the 2 times t minus means plus into c. So in place of c we have to place now minus natural log of 2. So it becomes minus natural log of 2. Now we have to format this equation for t. So it becomes natural log of n divided by 3 times n naught minus n plus the natural log of 2 comes in the other side, it becomes plus 1 plus natural log of 2 is equal to the 2 times of t. So by dividing the 2 in the other side, it becomes t is equal to the 1 by 2 natural log of n divided by 3 times n naught minus n plus natural log of 2. Now this is the general is a particular solution. We have to place now the conditions to find out the time for what value of time the population reaches to what value. Okay, so in the question we have been asked that find the moment of the time when the population reaches to 2 times t. Okay, we have to find the time when the population reaches to 2 times n naught. Okay, 2 times n naught. Now in place of n we have to place 2 times n naught. So t we have to be find out for n is equal to the 2 times of n naught. So it's become t is equal to the 1 by 2 natural log of, in place of n we have to place 2 times n naught divided by natural log of natural log of 2 times n naught divided by 3 times n naught minus 2 times n naught plus natural log of 2 is a constant as it is. Now by simplifying this one, it gives in the numerator it's remain as it is 2 times n naught. In the denominator 3 minus 2, it gives us only a single n naught. So the n naught here cancel out, it gives us natural log of 2. Natural log of 2 plus natural log of 2 gives us 2 times natural log of 2. A plus a gives us 2 times a. So as it is, natural log of 2 plus natural log of 2 gives us 2 times natural log of 2. So the 2 will be cancelled out. So for the duration of time natural log of 2, the population of the city reaches to the double of its initial value. So in the option, it is option number C. Thank you for watching. Allah Hafiz.